Good morning. So today we're looking at the Leadership College Paper 2, 2016 November. In the previous video, the video cut out for some reason or other, so I'll just re-record this section that was missed out on. Okay. So we got up until, in our lesson, we got up until I think the end of question 4, towards the end of question 4. But as I indicated that the video just cut out, so I did something wrong, so I don't know, one of the two. So I'll just now fill in the questions that was lost. Okay. So the first question says P, which is negative 1 and 2, which is this point here, R, which is 3 and 0, and negative 3 and 0, which is Q, are the vertices of triangle in the Cartesian plane. PQ, we are also told that PQ is equal to PR. Okay? So the letters are equal there. Alright, so the first question says, so what I'm going to do is I'm going to write all the answers on the side. Okay? And then just fill in the information on the diagram and just delete the questions afterwards as to keep the diagram in focus. Okay. So the first question says determine the coordinates of E, which is the midpoint of PR. So they were looking for that coordinate E. Okay, so looking at that diagram already, we know that it's your x value and your y value is going to be positive by the looks of it. So in analytical geometry, your answer should make sense. So the midpoint is the midpoint formula, is x1 plus x2 over 2, y1 plus y2 over 2. Okay, so if you make this x1, that would be y1, and x2, y2. Okay, if you're a person that's getting confused all the time, write it down here on the side. Okay, so that you don't lose those marks there. These are fairly simple calculations here that you shouldn't lose marks for. So E is equal to negative 1 plus 3 over 2 and 2 plus 0 over 2, which gives you an E value of 1 and 1. Alright. In 2.2 it says show that A is equal to minus 2 if the midpoint of QR is 1 and negative 0 and negative 1. So if this is the midpoint, then those lengths are equal. So I'm going to use the midpoint theorem in the reverse. Okay? So we know that x1 plus x2, which is this here, gives us the x midpoint. Not so. So that's going to give you x mid. y1 plus y2 over 2 is going to give you y midpoint. Okay? Let's bring this over a bit. Alright. So what happens is that since A is on your y, I'm going to use this one. Okay, the x is already sorted. Alright? So we say y1, which is A, y2 is 0, equals negative 1. Okay? So we're going to say A plus 0 over 2 equals y m, the midpoint of the y coordinate of the midpoint, which is negative 1. So I cross multiply. So A plus 0 is A, negative 1 times 2 is negative 2. So there is A negative. Okay. So the coordinates of Q is negative 3 and negative 2. So in 2.3, the question says determine the gradient of EQ, the gradient of this line EQ. Okay? So how do you calculate the gradient? It's change in y but change in x. Okay, the gradient. So this is 2.3. The the gradient of EQ. It's y2 minus y1 over x2 minus x1. Okay, some people write that formula perfectly down when they do the substitution wrong. Okay, again, we know that without doing any calculation here, we know that EQ has to be a positive gradient because the graph is increasing. That's straight line. So if that is x1, y1, x2, y2. Okay? I'm just taking it away because I don't want to mess too much on the diagram. So the gradient of MQ is equal to minus 2 minus 1 over negative 3 minus 1. So that's going to give you negative 3 over negative 4, which is 3 over 4. Which confirms that the gradient is positive. Okay, so I'm going to fill that in there. So the gradient of EQ is 3 over 4. Then in 3.4, the question 2.4 says, calculate the distance of PQ. So how do you calculate distance? Distance formula. Okay, so I need to calculate the distance of that line. But bear in mind that whatever the distance of PQ is the same distance as QR. Why? Because we are told that PQ is equal to QR there. Okay. So how do you calculate distance? Distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay. So again, if I make this x1, y1, this would be, oops, wrong coordinate. If this is x1, y1, x1, y1, okay, x1, y1, this will be x2, y2. Okay, so we'll do the substitution now. It will simply be PQ equals the square root of negative 3 minus 1 squared plus negative 2 minus 2 squared. That would be 2 squared is 4 and 4 squared is 16 is 20, so it's 2 root 5 if I'm not mistaken. So it's going to be the square root of negative 3 plus 1 squared plus, open brackets, negative 2 minus 2 squared. It's 2 root 5, okay? Okay, this looks a bit weird. So I'm just going to fix the calculator quickly. Change the calculator completely. Close that. Okay, I hope that's better. Okay, so which by calculation we saw that this was 2 root 5. Not forgetting, which is also PR's. So PR is also 2 root 5. Just in case we need it later on. Alright. So the distance is sorted out. So get out. In question 2.5, we are told calculate the distance of QR. 2.5. Calculate the distance of QR. So QR is equal to, I don't need to write this distance formula down again. QR, which is this length here. Okay? So QR is going to be, if I make this x1, y1, it will be x2, y2. Okay? So it's going to be 3, negative 3 minus 3 squared plus negative 2 minus 0 squared. Okay, so that gives us 636 for 40. So it's going to be 2 root 10, if I'm not mistaken. It was always better to check. So it's going to be negative 3 minus 3 squared plus negative 2 plus 0 squared. Let's give it 2 root 10. Okay? So that's going to be 2 root 10. Okay? You can see this diagram is populated here a lot. Okay, so as you can see, I'm populating the diagram all the time. Okay? Then in 2.6, in question 2.6, we are told, show that, when it comes to show that or prove that question, you cannot use this information given to prove, not that, but am I in the wrong point? It says show that triangle is a right angle. So we can't use the fact that triangle PQR is a right angle triangle to prove it's a right angle triangle. Okay? So what we need to do is we need to identify, or in conclusion we're going to say that in 2.6 that triangle PQR is a right angle triangle. Okay? We are also told that QR is root 40. We know that. 2 root 10 is root 40. Okay? So there's one of two ways you could have done it. If this was a right angle triangle, then the theorem of Pythagoras could be applied here, with that being a hypotenuse. Okay? So if it was a right angle triangle, then at P, then we could have said QR, which is the hypotenuse, squared is equal to P Q squared plus PR squared. This would have been a Pythagorean theorem there, with angle P being 90. Okay? With angle P being 90. But since it's not a right angle triangle, we must prove it's a right angle triangle. We're going to prove that this actually works, or can work in the triangle. Okay, so how do we do that? So this is the left and right hand side story. So on the left hand side we have QR squared is equal to, now what is QR? We know it's going to be the root of 40 or 2 root 10 squared, which is 40. Okay, so that's the right hand side. Let's look at the left hand side. So we know that QP squared plus PR squared is equal to QP squared, which is 2 root 5 squared plus 2 root 5 squared. Okay? Which is 4 times 5 is 20 plus 20 is 40. So you see that that is equal to that. So we say since QR squared is equal to QP squared plus PR squared, which is equal to 40. We just proved now it's 40. So therefore, triangle, we state the obvious, PQR is a right angle at P. Right angle at P. Okay? Right angle at P. And the reason for that is because it's the converse. As we know, it's the reverse of the theorem of Pythagoras. Converse of the Pythagorean theorem. Okay? The converse of Pythagoras. Okay, otherwise there's another way I could have done the same calculation, the same thing. We could have said that we could have worked with the gradients. Okay? So we work out the gradient of QP. The gradient of QP is going to be, what's that, 2 minus 2 over negative 1 minus 3, which is 4 over 2, which is 2. Alright, so now we need the gradient of PR. So it will be 2 minus 0 over negative 1 minus 3, which is 2 over negative 4, which is negative 1. So we say since the gradient of QP times the gradient of PR is equal to 2 times negative half, which is negative 1. Okay? So we know that lines of perpendicular product of the two gradients is minus 1. Therefore, triangle PQR is a right angled triangle at angle P. Okay, suppose I've said it's a right angled at P. Okay, that's any one of the two ways, you'll get the full mark for the summary. Okay, zero putting that information just in case we need it. Okay, that was the gradient of PQ, which was 2, and the gradient of PR, which is negative half. Okay. Okay, the next question. There's a few questions remaining. Okay, so in question 2.7 they say calculate the area of triangle PQR. Now how do you calculate the area of a triangle? The area is equal to half base times height. Remember this is 90 degrees, we proved that to be 90. So this will be your base and that will be your height, or vice versa. Okay? So it's going to be half QP times PR. Okay, so the area is going to be half QP is 2 root 5 times 2 root 5, which is 2 times 5, which is 10 units squared. Okay, so the area of this whole triangle is 10 units squared. Okay, then they want to know the area, they want to know the area, I'm going to write down the ratio of the area of triangle, the area of triangle PQE is to the area of triangle PQR. So PQR is a big triangle there, which is 10 units. Okay, the area of triangle PQE, which is this triangle. As we know that this is the midpoint here. Okay, we could have gone half base, which is 2 root 5, times height, which is that the whole length is 2 root 5. That is just going to be root 5. But we know that this is also known as your median. Okay? Your median is a line joining from one vertex to the midpoint of the opposite side. Okay? That median, this line is called the median. The median divides the area of the triangle in half. So I already knew this would have been 1:2. But say you didn't know that. It would have been 5:10 divided by 5 throughout. So you'll get 1:2. Okay? So let's look at question 3. Okay, so in question 3, the question says, let's see, let's just check the paper. It's 3.1. (3.1, 3.2, 3.4). Okay. So determine the value of the following expression by using a calculator. So that is fairly simple. So when we punch that in our calculator, please ensure that your calculator is in degrees. If it's not, you press shift. Number 9, you're going to clear all. So it's now 3 equals reset. So we now press, on top now you'll see a D in the calculator, which means degrees. So you say 2 sine 137.8. Okay? Gives us an answer of 101.34. Okay, as you see, they didn't specify how many decimal places. However, in the introduction to the sum, to the question, they told you that the sums must be rounded off to 2 decimal places. Okay, the next one is sec. As we know, you've got sine, cos, and tan. Then we got cot, sec, and cosec. Okay, so 1 over sine is the other way around. Sine, cos, tan, cot, sec, cosec. Okay, so 1 over tan is cot, 1 over cos is sec, and so on. So remember that the 3 is only a coefficient. So that would be 3 times 1 over cos 50. Okay, because sec is the reciprocal of cos. You can write it like that, or I could have written it as 3 over cos 50, which is the same thing. So it's 3 over cos 50 gives us an answer of 4,67. So 4,67. The next one is a substitution here. So remember that tan squared, your tan squared to 88.2 is an actual fact. Tan to 88.2 squared. The whole answer is the answer that's coming from that is being squared. Okay. So when you punch it in the calculator, we enter 3 open brackets tan 288.2 squared times cos 164.6. Okay, that's over open bracket sine 199.4 squared plus cos 150.2. Okay, it gives you 35.32. It's 35.32. Okay, 3.2. The question says determine the values of theta in each of the following equations. Alpha is equal to 90. Alpha is an element of 90 from 0 to 90, which means to say the alpha angle is an acute angle, or you can throw it in the first quadrant. Round off your answer correct to 1 decimal place. So here you explicitly was instructed which your answer should be in 1 decimal place. Okay, take it over the equal sign, it becomes positive. Alpha is equal to R cos, or shift cos of 0,832. So we go R cos, shift cos of 0,832 is just 33,69. So to 1 decimal place is going to be 33,7 degrees. Okay, the next question. We're going to divide by half first both sides. Okay, so we have inside alpha equals, that's 0,428 I think. 0.214 divided by 0.5. 0.428. What I could have written its fraction equivalent. Alpha is equal to arc sine of 0.428. You don't need a bracket there. Just a habit of mine of doing more. The arc sine of 0.428. 25.3 degrees. Alright. Next one. Next one we have cosec. As we know, cosec is the reciprocal of sine. So it's 1 over sine alpha is equal to 3. So naturally that's over 1. I cross multiply. So it's 3 sine alpha equals 1. So sine alpha is equal to a third. So alpha is equal to arc sine of a third. Okay. In the calculator, arc sine of a third, usually 19.5 degrees. Okay. The next one, I'm just trying to get through this question before the this. Okay. The next one, I need to divide by 3 first, both sides. The idea is to get tan standing on its own. So tan of alpha minus 20 equals 1.43. 1.43 divided by 3 gives us 0.477. So now you say alpha minus 20. You can't take 20 over the equal sign. Okay? You must first take arctan. So arctan of 0.477, or you're going to use the answer but of course. So you got arctan of that answer is at 25.48. You take 20 over the equal sign, it becomes plus 20. Plus 20 gives us an answer of 45.5 degrees. Okay. So alpha is equal to 45.5 degrees. And we can check it, people. Wherever we see alpha, we put that value. And since the first answer calculated, I just press the answer button. So I say 3 tan answer minus 20 degrees should give you an answer of 1.43. As you can see there, it's exactly that, since I've used the answer button. However, if I had punched in 45.5, then you will see it's a very close answer to 1.43. Okay? So the answer is more precise. In question 4 and question 3.3, we are told if tan of A is equal to 4 and A is less than 90, which means to say it's in the first quadrant. So we divide by 3 both sides. So tan of A is equal to 4 over 3. What does tan stand for? Opposite of adjacent. So what's my opposite? 4. Adjacent? 3. So I apply Pythagoras to get the hypotenuse, which is 8 squared is equal to 3 squared plus 4 squared. Gives you a value of 5. 25, that would be wrong. But the question was to calculate the value of 5 cos squared A plus 10 sine squared A. So that will be 5 cos is adjacent over hypotenuse squared plus 10 times your opposite, which is 4, relative to this angle. There's your A. Is going to be opposite, which is 4 over 5 squared. So that's going to give you a 9 over 5 plus, that's going to give you 1632 over 5, which is 41 over 4. Okay? 4.4, which is the last question. They say prove without using a calculator that. So this takes you to the special triangle. So at this point you should know the special triangles that we had. So it's 30, 1, 2, root 3. Here's 60 degrees. And 45 degree, you have a sausage triangle here. So it's 1, 1, and root 2. And one that is not a triangle but works for what we're working with. That is 90, 90, it's 0. It's 0, 1, 1. So this is an identity left and right hand side story. So let's look at the left hand side. So you got tan of 60. Now tan of 60, tan is opposite over adjacent. That's tan. So it's going to be root 3 over 1, which is root 3. So if you can prove that the right hand side is also root 3, I've done the job. So for the right hand side, we say that would be simply cos 30 degrees over sine 30 degrees. So cos of 30, cos is adjacent of hypotenuse, so it's root 3 over 2. This line here means divide. So I divided line. Sine of 30 is opposite, so it's 1 over 2. So that's going to be root 3 over 2 times 2 over 1. It cancels, which in turn equals, let's push this down a bit. Which in turn equals root 3. You see that the left hand side indeed is equal to the right hand side. Okay, so we just conclude equals the left hand side. Alright.